Alright guys, welcome to the method of partial fractions part 3. This is take 4 because my memory card was full. Note to self, make sure the memory card is empty before you record. In case 3 we're going to be looking at quadratic factors. Okay, so for each factor of this form, the partial fraction decomposition must include the following sum of fractions. So I look at that and I just kind of smile, and you might think, what does that even mean? Like this fraction, this fraction, this fraction. Well, I can spout all this off to you and you can say, well, great, what does that mean? Why don't we look at an example so we can see something that's concrete of what it looks like with the following sum of partial fractions. Okay, so we have a quadratic, at least in the denominator here. So we have 2x cubed. We're going to integrate in example 1, 2x cubed minus 4x minus 8 all over the quantity x squared minus x times the quantity x squared plus 4 dx. Just like before, start by factoring the denominator. So here's my denominator. I can only factor x squared minus x. It has a common x, so I wrote that in red. That's my factor. Okay, and then x squared plus 4. There's no integers that can factor that for us. And so we're going to have one partial fraction for each factor. Now here's where I say, let's look at what this means. Here's a concrete example versus just seeing a bunch of variables. Okay, so here's my fraction with the new factor denominator, and so we're going to have we're going to start with a over the first factor, which is x, times plus b over the second factor, plus cx plus d over x squared plus 4. So you might say, wait a minute, what does this mean? Well, remember, we want the numerator to have a power less than the denominator by 1. So these are both linear. So this would be a constant, this would be a constant, and now this is a quadratic, so the term up here needs to be linear. So now we have cx plus d. We actually have 4 variables we need to find, a, b, c, and d. Fortunately for us, we can start a and b the same way we've done before. So we're going to multiply by the least common denominator to yield our basic equation. So you get 2x cubed minus 4x minus 8. Again, here's our basic equation, the rest of it. A times the quantity x minus 1 times x squared plus 4. B times x squared plus 4 plus c x plus d times x minus 1. So now we got to find a. Now a is associated with 0, or x, a over x, right? So we're going to let x equal 0, which is going to cancel out this term because of the x and our third term because of the x. So all of this is going to go to 0. So when we let x equal 0, we get negative 8, right? 0 minus 4 times 0 minus 8 equals a times negative 1 plus, or times 4, right? 0 minus 1 is negative 1, and 0 squared plus 4 is 4, plus 0 plus 0. Again, these two terms are gone because when you let x equal 0, you get 0 times some number. Okay? This ends up giving us a equals 2 when we solve that. Now, b was over x minus 1. So to solve for b, we're going to let x equal 1 because that's going to eliminate this term because of the x minus 1 and this term because of the x minus 1. And we're just left with the middle there. So we get negative 10 when we substitute 1 in. So 2 minus 4, right, minus 8. Okay, gives us negative 10 equals 0 plus b times 5 plus 0. So again, the first and last term becomes 0. Solving for b, I get negative 2. Now, here's where we do something different versus the other videos. We're going to have to use systems. So, to find c and d, we let x be some number, any number. In this case, I'll let it be negative 1. We can use a equals 2 and b equals negative 2. Now, you might say, well, I can use any number. Why not 0? Because we've already used 0, right, when we found a. So, we're going to let x equal negative 1 in this case. And so when I plug in to my basic equation, a equals 2, b equals negative 2, and x equals negative 1, here's what I'm left with. I plug in, I get negative 6 equals 2 times negative 2 times 5 plus negative 2 times negative 1 plus 5 plus negative c plus d times negative 1 times negative 2. So we end up with the equation 2 equals negative c plus d, okay? I let x equal some other number, I called it 2, and I'll still let a equal 2, b equal negative 2. And I go ahead, here's my basic equation, okay? And I get 8 equals 2c plus d. So now I have to solve the system between these two red equations. Okay, so I go ahead now and we're going to solve the system, and I'm assuming you can solve the systems. We can go ahead and subtract those fairly quickly and find what C is first. The solution to the system is C equals 2 and D equals 4. So the partial fraction decomposition is the following. Here's the original. So we're integrating equals 2 over x minus 2 over x minus 1 plus 2x over this, x squared plus 4 plus 4 over x squared plus 4. I separated these two fractions, the cx plus d. So now let's integrate. Now, we want you to remember, I don't want our board to fall. We want you to remember, I just rewrote the problem here, the following. U substitution, if you have 1 over u, you get natural log, and if you have 1 over u squared plus a squared dx, it's inverse tangent. So when I integrate each of these, I get 2 ln of x minus 2 times the ln of x minus 1, it's absolute value, okay? Depending on the text, they'll have absolute value. I could put absolute value here, but most of us know that natural log has to be greater than 0. So then the third term helps us. We get ln of x squared plus 4, and we get plus 2 inverse tangent of x over 2 plus c. So that is the integral. That's what our antiderivatives when we use partial fractions, and I use these two definitions to help us finish this. Again, we're assuming at this point, since if you've watched the first two videos, we know some of these integrals fairly quickly. Okay, I didn't go through and use substitution here and so on and so forth. Okay, if you have questions or comments, you can go ahead and type them below, and we'll see you next time.